Let's move on to the Winbind section of Samba, where we integrate our Samba server with Active Directory, allowing our users the ability to log in without having a locally defined user account. So the technology is called Winbind. It's included with Samba, and again, it features Windows AD integration. It also will integrate with any Windows server, making those remote user accounts available to the local Linux system. As a consequence, when properly integrated, users need not be defined in two places. So, avoids having to define users in two places. Of course, one being on the Windows system, the other being on the Linux system. So Winbind is a driver, it's a module, and it integrates with Samba, and it speaks to Active Directory using Kerberos. So it uses Kerberos for authentication. And it requires multiple steps to get it going, and it needs to have certain things in place for it to work, which we'll document. So what are those requirements? Well, first and foremost, we need to have Kerberos installed. So Kerberos, implemented via the kerblibs package, is required. You can save yourself the hassle by installing all kerb5 star packages. However, the primary configuration file that we're interested in is etc kerb5.conf, and this file is owned by the kerb5-libs package. So this is the important package, but again, you can save yourself the hassle by ensuring that all kerb5 packages are installed. rpm query all grep kerb5 will reveal just that momentarily. We've got libs, workstation, PAM, which is a plugin, development, and off dialog. So, providing that the Kerberos packages are installed, we need to ensure that we configure the Kerberos environment to support Active Directory. So to properly configured Kerberos environment, and that entails manipulating etc kerb5.conf. And there's documentation all over the web on how to do it. However, we will give you the directives that are required for connecting to a single Active Directory environment. You need to ensure that the following are in place. Lib defaults. This is at the top of the kerb5.conf document. And we can back up the existing one so that we don't lose the changes. We need to set a default realm. And the default realm is equivalent to the name of the realm, the domain that was used to define the Active Directory environment. That domain is currently set to AD2, although we've yet to connect to the server, using uppercase AD2 linuxcbt.internal. Then we need to define a realms section, and in here we'll duplicate this information. The realm that we're interested in uppercase, and it's important that you follow the case, is AD2 linuxcbt.internal. And it's equivalent to the following directives. We're going to describe which server is responsible for the realm. KDC is the directives we'll use. linuxcbt win3 is the name of the server. .ad2.linuxcbt.internal. We'll also define an admin server, setting it equivalent to linuxcbt win3, and then we'll terminate the block using close curly braces or a close ellipse. In addition to the realm section, we need a domain_realm section, which also references the server and the realm. So domain_realm, and in here we'll indicate the name of the server, .linuxcbt win3, AD2 linuxcbt internal, setting it equivalent to the name of the realm, which is AD2 linuxcbt.internal uppercase. So we've got the three sections that are important: lib defaults, realms, and domain_realm. Now before we paste these items into the config file, we can take a look at the existing file. We'll copy it to back it up. So let's navigate to etc and copy curb5.conf to curb5.conf.back, and then we'll modify curb5.conf. There's a logging section which logs transactions related to Kerberos. There is a lib default section which we'll remove, a realm section which we will replace, a domain realm section which we'll also replace, and the KDC section which is a pointer to a config file which we'll leave, and app default we'll leave. These are just defaults for Kerberos regarding the tickets that are used for authentication. So basically we need to gut this file, removing lib defaults, realms, and domain realm blocks. In here we'll paste the settings that are specific to our Active Directory environment, beginning with lib defaults and terminating with domain_realm. Let's paste, and now we've got these settings in here. And we'll just include a comment that it was modified to support Active Directory. And we'll cut, paste, and then paste below so that we know that this block belongs together. Super. So now we've got our directives in place as far as Kerberos is concerned. Remember, Active Directory authentication relies upon Kerberos, and Winbind relies upon a proper Kerberos configuration to be able to communicate securely with the Active Directory domain. So with that said, let's save the changes to curb5.conf and move on to subsequent steps, which includes joining the domain after having updated the Samba configuration file, testing that we've joined the domain properly, so on and so forth. Let's label the section steps. Step 1 is update etc curb5.conf. Step 2 is update Samba configuration to use AD or ADS authentication. And we can do this with SWAT. So let's navigate to the SWAT interface. We'll close the help, which was launched into a separate browser instance, and then navigate to SWAT. So if we navigate to the global section, in basic mode we'll see settings, workgroup, realm, off type, you name it. We'll set the realm to 82 linuxcbt.internal. We'll also set the authentication type, the security type, that is, to ADS. This is important. So we need to be sure that we set ADS and also set the realm to 82.linuxcbt.internal. Another thing that we should do, let's go ahead and save the changes. We'll commit changes. This will update the configuration. Another thing that we must do, unless your DNS is already set up, is update Samba servers DNS to point to ADS server, or to point to the servers that provide DNS information for your Active Directory domain. In this case, our Windows Active Directory server is the default DNS server, or is the DNS server that we'd like to use. So with that said, we're going to update etcresolve.conf, and we should just indicate that indeed it's etcresolve.conf. That's nano resolve conf, and we're going to include a default name server of 192.168.75.225. That's what we'll set the servers, or the server's IP address will be. That'll be default. Another thing that we must do to make the configuration work well is to update etc hosts, including pointers, or including a pointer to the ADS server. So in our hosts file, just to be sure that in the event that DNS breaks down, Kerberos is still able to find the server, place the entry in the hosts file. That'll just save us from any unforeseen trouble. So the IP address of the server is as follows, and its name is Linux CBT 2K3 with the following name as its domain part, and its short name is simply 2K3. So this way the server will be able to connect to the domain. We'll save the changes, and that's in place. We've updated etc hosts, including a pointer to the ADS server Linux CBT 2K3. And we've got that indicated in our config file. In fact, we have it specified as Win3, Linux CBT Win3. So let's just double check that by using our desktop, full screen, 16-bit depth, and the host's IP is 225. This will tell us the name of the server once we connect. And we'll have a desktop momentarily. We'll execute hostname to ascertain the hostname. So it's indeed Linux CBT Win3. We can also confirm the Active Directory configuration since we're on the system. We'll launch Active Directory users and computers. And there we see the name of the domain is ad2.linuxcbt.internal. So with that said, let's log off from this session and double check our configuration. That should be for Linux CBT Win3. Indeed, this is correct. So we'll update 2K3 to be Win3. And in etc hosts, we'll be sure to have that specified. Let's change it in the long name and save the changes. Great. So now if we attempt to send 3 packets to Linux CBT Win3, it should respond, and it does. Excellent. So in continuing with our studies, we need to move forward. Now before attempting to join the domain, let's restart all services by navigating to Status, Restart All, and then check that SMBD as well as NMBD and Winbind D have all been restarted. And it says it's not running. Let's refresh the page. And now it shows that SMBD and NMBD are running, but Winbind is currently not running, which is fine. So now we've restarted the daemons, let's attempt to join the domain using the net command. So our next step is to join Active Directory domain using net ADS. Let's put it between single quotes to ensure that you interpolate the spaces to mean explicit spaces at the command line. So ADS join U administrator will authenticate as the administrator user or a user with administrative privileges, domain administrative privileges, to join the domain. Enough to join the domain. We're prompted, and we'll indicate administrator's password, and momentarily after the client, our Samba server, has contacted the remote system, the ADS server will have access to the domain, and we'll confirm that the computer account has been created by creating a terminal services session to the server and using Active Directory users and computers to confirm. So all this joins will list as the next step. Fifth, confirm AD membership using the Active Directory users and computers tool. Which entails, of course, creating a session on the system. And here it says joined Linux CBT Serve 1 to Realm 82linuxcbt.internal. So again, let's just rerun our desktop using the history shebang. We'll log in as administrator, and we should have a desktop momentarily. We'll launch Active Directory users and computers, and we'll navigate to the computers section where we should see, and we already are in the computers container, where we see an object for Linux CBT serve1, which was created as a result of using the netads join command. So great, we're now a member of the domain, which means we can participate in domain functions such as authentication. Now Winbind isn't yet fully set up, but as far as our Linux Red Hat Enterprise box is concerned, it knows of the domain, it knows how to talk to it, and we could pass off authentication to it. But the next critical series of steps is to set up Winbind. So 6, set up Winbind to authenticate using ADS, and this involves multiple steps that you have to follow to ensure success. First and foremost, we should confirm that the PAM or Pluggable Authentications module environment is ideal. There are 2 entries that we're concerned about. They include the auth as well as account entries. We need to ensure that there are references to the PAM Winbind module in those files. Now on Red Hat Enterprise Linux, if you navigate to etc pamd, since we're currently beneath etc, and ls, you'll see multiple items. But we're interested in the items that are responsible for authentication and accounting. You will find those entries in the system auth file. So we are interested in updating, for this version of Red Hat Enterprise, etc pamd, which is a directory that is defined to hold or created to hold multiple distinct PAM entries like logrotate.d or zinetd.d. This file has the account, so it has account and auth settings that we need to reference to PAM Winbind. So let's clear screen and nano system auth. There are many settings for auth, account, password, and session, the 4 areas in which PAM does its work. But we need to be sure that we place Winbind before the auth required for PAM_Unix. So we see PAM_Unix, sufficient, PAM environment. We need to be sure that we place PAM Winbind before the auth required for PAM Unix. So a great place to place it would be here, and you can comment Winbind auth. And our entry would be auth, and PAM is stackable, so if an item which is sufficient meets the prerequisite occurs before something else or before another option, then PAM will accept credentials or accept the authentication or the particular function. So it's stackable, but first come, first serve, or first authenticates, first grants, first wins. So auth, and we'll define our type as sufficient, with a reference to where the module is located, either explicitly or relatively. Explicitly would be /lib security, referencing the full or absolute path, pam_winbind.so. We could alternatively simply indicate pam_winbind.so because it's in the path. In other words, the other modules that PAM loads can be found in lib security. We also need an entry for the account section, which references PAM Winbind. The auth section handles authentication to be sure the user's credentials have checked out. The accounting section happens to handle the management of accounting of a user's account to be sure that the account is permitted to do things such as logging on to the system. So again, we need an entry for PAM Winbind, and we'll place it here as account sufficient lib security pam_winbind.so. And again, this is used for Winbind auth. So these are our 2 entries. Let's save the changes to the file, and we still have more steps before this is up and running. So we've updated, including our auth and accounting settings. Now let's just note those settings. Auth sufficient, lib security, pam_winbind.so, and account sufficient win_bind.so, and place this before pam_unix.so, which happens to be the general purpose authentication module that PAM references. Next step is to update etc/nsswitch.conf. This is the name service configuration file, which tells programs in Linux how to find various databases, such as user accounts and lookups for different types of resolutions like hosts, LDAP, NIS, and others. So it's a centralized lookup table. We need to make the following changes. For the password line, we'll append to files Winbind. This means that whenever a user authenticates to the system, PAM or NS switches to instruct the application, such as login, to consult files first, which includes etc password and etc shadow, and secondarily consult Winbind. We also need to do the same for groups, because there will be groups defined on the Active Directory server or in Active Directory that we'll want to take advantage of. So we'll include a files Winbind line for group as well, so that both groups and users can be resolved. Let's go ahead and update our nsswitch.conf file. You'll see the defaults that are set, commented most of it, and for password it's currently set to simply files. We want files as well as Winbind. For group, we want files as well as Winbind. There are other types of tables that can be looked up, such as hosts, which defaults to files and DNS, which means search etc hosts, then consult DNS, but we could alternatively indicate other lookup sources like a specific database or NIS or NIS Plus, and other items, services, networks, protocols, any sort of mapping information that we're likely to make use of throughout our experience on our Linux system is referenced via etc/nsswitch.conf. So when we're looking up ethers or netmasks or protocols or services or RPCs, all of this is handled by nsswitch.conf. It's just a lookup table. So we'll switch to our documentation and move on to the next step. Step C, configure ID maps for UIDs and GIDs for Winbind usage. And we'll set a range of 1 or 10,000, that is, to 20,000. In your environment, if you anticipate more users, then specify a wider range. This setting handles the IDs that Winbind will dynamically assign to Windows users or users from the Active Directory configuration. So it needs a set of users, because if you recall, with file system permissions in Linux, the references are really made at all times to user IDs. When we use tools like ls in long format using -l, the user's name and group name are returned. However, resolution always is based on the UIDs associated and GIDs associated with files. So that said, every connecting Windows user from Active Directory needs to have a unique UID as well as GID. And Winbind takes care of or handles those mappings for us. Now we configure this using SWAT, but we could optionally configure it using by modifying directly etc samba smb.conf. Use SWAT to update ID map settings for UID and GID. With that said, let's return to our browser where we should find an instance of SWAT. We'll then navigate to the global section, and there's a Winbind section towards the bottom of the global section. And we'll scroll down, and here we see ID map, domains, ID map, backend, and Winbind NSS info. Notice no indication of UIDs and GIDs, which is why we need to navigate into advanced view. So again, there are settings that are hidden, but nonetheless, we can expose them by clicking on advanced or by inserting the directive into the etc samba smb.conf file. So now we see the additional directives, which includes the ID map UID range and GID range. If you click on help, it pops up another window which gives you some inclination as to how to configure the directive. It takes a little while to come back. It'll be back shortly. And again, you'll see you can set the range 10,000-20,000. So we use the range described in the documentation. So with that said, let's go ahead and insert it into the Samba SWAT configuration for both UIDs and GIDs, 10,000 through 20,000. And we want the UIDs and GIDs to be identical as they are in Red Hat Enterprise Linux. Now we're still not done. There are always additional changes that we need to make the environment work exactly how we want it to. For example, if you want your users from Windows, from Active Directory, to be able to log in using a shell-based application such as SSH, Telnet, or from the min-getty processes listening to the various TTYs, you need to change bin false, the template shell, to a legitimate shell. So let's just note, if you want ADS users to be able to log on to your Samba Winbind Linux box using SSH, Telnet, min-getty, etc., change the template shell directive to a valid shell, i.e. bin bash, as is the case for standard users defined in etc password. So bin bash will ensure that when users log in, they have access to a shell using bin bash. And there are yet still other settings such as the Winbind separator, how to separate, let's say, the domain name from the username. So we'll see momentarily Linux Genius, uppercase, / followed by a user or group name, whether or not to enumerate users, refresh items, whether or not the tickets should be refreshed, whether or not we should allow trusted domains only, whether or not we should use a default domain, which is Linux Genius specified in the Kerberos configuration file. And again, you click on help and it takes you to the default domain directive. It tells you, it specifies whether it should operate on users without domain component in their username, and they tell you that it's treated as a user who's local on the system, but it makes SSH, FTP, and so on easier. But we'll leave it as no for now so that you see what the users look like and how you'd gain access to the system using the domain versus not using the domain. The important directives for now include the ID map, UIDs, and GIDs, as well as the bin bash directive. One other point, and there are always many other points, but one other point is that Samba will expect to create the user's home directory beneath /home, which is obvious, but %d, which is the placeholder or variable to represent the domain. So be sure that you also create a domain directory beneath home so that Samba can create a user directory for your user. So D, update template, and let's just get that exact name. It should be template directory, template home directory variable. Home directory, or create, it's really create template home directory %d, or domain directory beneath /home. So in our case, we're going to make directory home uppercase Linux Genius, and this will be the container for users from the domain, and Samba will take care of the rest. So with that said, let's make directory home Linux Genius. It doesn't do it for us automatically, and if you don't create this directory, when users attempt to log in using a tool like SSH, Telnet, etc., the Samba process will throw an error because it will not find the top level container which matches %d to be able to create the second level container of the user's home directory, which is represented by %U. With that said, or with all of that said, let's commit the changes to the configuration. When you commit changes, you can always navigate over to View to see what the configuration looks like, the actual smb.conf file. We'll wait for this to be updated. Navigate to View. And in the smb.conf, the superfluous items, the comments, have been parsed out for the most part. And now notice ID map, GID, UID, template shell, bin bash. These are the settings that we just worked on. Again, whenever you make changes, if you can, if it doesn't impact your users, it's always a good idea to navigate to status and restart all of the services. If not, then you'll have to wait until you can, but it never hurts to restart, as it forces the daemons to reread the smb.conf file. It takes a little while for all the services to come up. SMBD will be up shortly, but notice currently NMBD and WinbindD are both running. From the shell, always confirm PSEF grep NMBD. Ditto for Winbind. And then we check for SMB. Now with that said, we should be very close to actually making use of Winbind integration. So let's give it a try. That leads us to the next step, which is to execute wb-info. Now let's just witch it so that you know which program or where it is and which program owns it. User bin wb-info, Samba common. wb-info enumerates using Winbind users and groups from remote Windows services. So wb-info-help returns its myriad options. All sorts of options are supported, but the simple options include enumeration of the user or the groups that are on the server, so users or groups. So wb-info-u will enumerate the users from the remote Active Directory, prefixed by the domain, followed by a backslash. Let's just update our notes that the next step is to test it all. So 7, test Winbind integration using wb-info. So the first step is or the first test, and in no particular order, is wb-info-u. This enumerates users in AD. The next step is to enumerate the groups using wb-info-g. And this enumerates groups in AD. The reason why you perform this test is to make the determination as to whether or not Winbind can successfully talk to Active Directory. Here are the groups. If it can, you're ready to use Winbind. As you can see, this is working. This is exactly what we anticipated. And we can now perform additional tests, such as trying to log in as a user. So on the domain, we have various users. Administrator, so on and so forth. We could try to log in as Linux Genius Administrator, or we could create a new user on a remote system like Linux CBT and try to log in as that user to see how it differs from the local user. Now before we log in as the user, which is another test, so C SSH into Linux CBT serve1, which is running Samba Winbind as ADS user. Before doing so, let's create the directory for the users, or the user's home directory beneath home Linux Genius. We'll make directory home Linux Genius administrator, and we will chown it to be owned by the user Linux Genius administrator. We'll escape the backslash by indicating 2 backslashes. And now when we LSL home Linux Genius administrator, and let's LSLD, we'll see that the directory is owned by the domain user administrator, and optionally root, but we could change this as well. So now when we attempt to SSH in as a user, the user will be parked into their home directory. So let's clear screen SSH as the following: administrator, lowercase that is, at localhost. This prompts us for a password. Now this password needs to check out with what's on Active or what's in Active Directory, and it has. So now we're in our home directory. We can interact, we can create files, so on and so forth. So we've logged in without creating a user named administrator. There is no such user in our local user account database, etc password. And again, we can do this for additional users. Let's log out. We'll make directory home Linux Genius. We'll call this user Linux CBT. This is going to be a distinct user. And then we'll connect to the Active Directory system and create this user, and then chown the permissions so that the home directory is owned by the AD user. And another note we should stick in there is that if you create users in Active Directory and you don't see them immediately available in your Samba environment, try restarting the Winbind service. Sometimes it doesn't update automatically or in real time. So let's go to the users container and define a new user, just a normal user, not a super user. User's name, Linux CBT. Login name, we'll skip the other fields. Will simply be Linux CBT. And we don't need to restart, or change the password, that is. So now we have a new user named Linux CBT. Let's log off this box. And then from the shell we'll use wbinfo again to see whether or not we see the user. So wbinfo-u enumerates, and notice it sees it, but it doesn't always work. I've seen in production environments where it's not consistent. So again, just be wary of that. In this case it works maybe in a real busy network environment where packets get lost or utilization's high. Perhaps you won't see it immediately, or separated by multiple subnets. Right now everything works because we're in a controlled environment. The systems are all on a flat subnet with the exception of the DMZ boxes. So with that said, let's chown. Let's navigate to home, Linux Genius. If we LSL, you'll see the items. Let's chown Linux Genius, the name of the user, the name of the home directory. We could alternately indicate a generic group such as users if the users group exists. Exit status should be clean, although we missed it. And there the user now owns this directory, which means if we attempt to SSH as the user from the domain, and again, we're using Linux Genius, although the Active Directory name is ad2.linuxcbt.internal, the Active Directory still emulates a 15-character NetBIOS name, or up to 15-character NetBIOS name. So let's log in as the user at localhost, indicate the password, and now we are logged in with a bash shell into our home directory. Again, these users do not exist in the Linux box. Linux Genius, Linux CBT is a different user from home Linux CBT, two different users. Now how about connectivity from Windows? Since most of your desktops are likely to be Windows, what's the view from there? If you log into a Windows box as a given user, will you then be able to connect to this Samba instance, which is running in ADS mode? And the answer is, of course, yes. !r desktop. This brings up a session. We'll log in as administrator. Fresh session. And then attempt to connect to the Samba server momentarily. Let's launch an instance of Explorer or command line. Start Linux CBT serve 1. This will bring up the remote system and attempt to authenticate us. And there it is. Notice we were not prompted. Let's double click on the administrator, and there it is. We're in, we're logged in, we can interact with files, so on and so forth. This is because the format of the file doesn't comply with Windows in terms of line delimiters, so it doesn't actually have beyond one line. Everything's on one line. You can fix that using Unix to DOS. But the fact remains, we are now authenticated to the Linux box using Winbind, and we did not have to prompt for authentication. Now what about creating additional shares and gaining access to those shares? Well, let's do so through PuTTY or through the browser. Well, the browser won't connect us from here because Samba is restricted, and that's how it should be. So let's log off briefly. And we're going to create a directory at the root of the file system. Let's make it a name called project. Then we need a group to assign to this project directory that Windows users will share. So wbinfo-g, and we see that we have domain users as well as domain computers. We need like a generic group to lump people into. So let's our desktop again. We'll be in momentarily. And we'll launch Active Directory users and computers and create a group to which Linux CBT and administrator will belong. So in users, right button, launch new, we want a new group. We'll call this group project, or call it project managers. And it's a security group, not an email distribution group. Then let's make administrator as well as Linux CBT members. They're now members, which means we can assign those permissions using chown to the /project directory, and then try to access the directory after publishing it as a share. So let's wbinfo group again, and we should see momentarily. Again, if it doesn't update automatically, then you can restart Winbind. So here we notice that we don't see the project managers group. And an easy way to affect this change, again, is to restart the service if you don't see it. And we should also note that if you're fearful of losing connections, then reload as opposed to restart. So we'll service Winbind. Reload. And then try wbinfo again, at which point you see project managers. So let's just list. Those are steps, and we've been moving off to tasks now. So task 1 was to authenticate using ADS as administrator from Windows box. Task 2 is to create a shared or create a user named Linux CBT in AD. Task 3, create a shared directory on the Samba box and provide access, which is what we're currently working on. So we've created this new group, and we want to assign rights to the directory. So let's chown Linux Genius project managers to the directory project at the root of the file system. And let's just double check what we're missing. We must have misspelled something. And that's the group, not the user, so it's change group. We have an opportunity now to use it. And let's lsld project. We see that the group has read execute rights, so we'll change mod 775 project. Now, any user who belongs to the Linux Genius Project Managers group will be able to connect using Samba to the project directory and write files. Again, let's LSLD it. You'll see it's now 775, or read, write, execute, read, write, execute, read, execute. So with that said, let's attempt as a user on the Winbox to connect to the share, as we've mentioned. But we do need to share it, so create shared directory on Samba box and provide access. By providing access, we mean share it. So using SWAT, we'll navigate to shares. This gives us the opportunity to create one. Create a new share, which we'll call it project. Now let's just make sure it matches what we have in the file system, and it is indeed singular. This share will be created, and we'll set some parameters governing access to the share by choosing the share, which it automatically does anyway. Comment, path, we must set a path, /project. Invalid, valid, admin, read, write, read only, no. Guess, okay, no. So you must have privileges. It is browsable. Let's commit the changes. If we view the configuration, we'll now see a new share defined in the shares section. We've got homes, printers, the defaults, and project. Now with that said, we'll connect to the Samba instance from the Windows instance by launching our desktop. This will place us back on the server. We can do this either as Linux CBT or as the user root or as a user administrator. In case of Linux CBT, it doesn't allow us to log in because it's a domain controller, which is what we expected. So let's log in as administrator. And once this comes up, we can either go to My Network Places or open a shell, a DOS box, and use the start command to connect, or just in Explorer indicate the name of the server. Linux CBT Deb2 is a prior trace from one of our studies. So we're connecting to Linux CBT Serve1. It will enumerate the shares on the remote system. Notice it doesn't show the project share. Whenever you don't see a share, reload the configuration. So again, that leads us to connecting to the remote system. Now, rather than dropping the session, we could launch a PuTTY instance to connect to the box, Linux CBT Serve1. Its IP address, 192.168.75.10. And we'll just save the settings and then open a connection, which will have to accept the public key of the system, which gets stored in the registry. And once we're on, we can service SMB reload. This rereads the configuration file, which usually is good enough to republish or to dynamically make available new shares. If it does not, then you may have to actually restart it, as we're seeing is the case in this particular instance. So let's go ahead and instead of a reload, we'll restart and then try again. But when you restart SMB, it also restarts NMB. Keep that in mind. So let's try it again. And also we should note that when you define a share using Samba, it sometimes will set the share to not available. So that's something else to keep in mind. So here it is, project. After having restarted it, we can access it. We can create items. Let's create a new folder. And there it has created it. Let's copy something to it. We'll copy this PuTTY executable installer for a slightly older version of PuTTY. And then since we've got a PuTTY window open, let's navigate to project and examine the contents of the permissions and items inside the directory. So notice default permissions for the domain users group and for the user administrator for the Linux CBT Win3 directory object is 755. For the file, however, it's 744. These are all tweakable in the Samba configuration on a per-share basis. The item is owned by administrator, the connecting user, who has access to the top-level directory to write, and it works. So again, we have a seamless integration of Winbind running here. You need to be sure that on the remote system, when the system reboots, Samba is set to start as usual. Check config list. SMB will ensure that it starts, or report whether or not it will start, and a check config with the appropriate levels, let's say 3 and 5 SMB on, will ensure that it starts. Let's list Winbind as well. It's off, so it needs to be set. And a recheck of Winbind will reveal that it's set to start in 3 and 5 as well. Now again, in etc init.d, don't expect to find an NMBD process. NMBD is controlled by SMBD. Let's log off, and we have set up Winbind integration. It's straightforward. There are multiple steps, and it's easy to make mistakes, but if you follow these steps, you should be close. Plus, there's also tons of documentation online to help you figure this out. When it works, it's beautiful because you can reap all of the benefits of using a Linux system while connecting from Windows, etc.